as you can see in this question, it is asked that the graph shows the variation of absolute temperature T of the pressure P of the fixed mass of an ideal gas. Okay, now we can imagine an example or visualize an example. There is a container. Okay, there are air molecule inside it, and number of air molecule will remain same, and hence the mass inside the container will remain constant. Now this graph shows that it is a linear graph. That means with temperature increases, pressure increases linearly, and when temperature decreases, pressure decreases linearly. That means this is P where is with T. This graph is of this equation. Okay, when temperature increases, pressure linearly increases. When temperature decreases, pressure linearly decreases, and the mass inside this container remains in. Now if I heat it, what will happen? The temperature increases, and that means when the pressure will increase in this case. That's the question, right? So if I increase the temperature, these molecules will move around with a higher kinetic energy. Now if the container size of the container or the shape of the container or the volume of the container remains same, that means when V is constant, then only pressure will remain same. Sorry, pressure will increase. Okay, because when I heat them, inside the temperature increases. Because of that, these molecules gain kinetic energy, and they move around with the higher kinetic energy, and they will strike the surfaces. And now if the volume remains constant, then only the pressure will increase. So we can say the volume is constant. Now since volume is constant, and we already told that the mass remains constant, inside the container, that means density is nothing but mass divided by volume, right? Volume. So if volume is constant, mass is constant, that means when volume is constant, density will be constant too. So as you can see, the first one is the correct answer. Volume constant, density is constant. When temperature increases, pressure increases. In that case, volume has to remain constant. And if the numbers of molecules inside the container remains same, there is no way out, then mass is also constant. In that case, density will be constant. So volume constant, density is constant. So this is the correct answer.